Okie dokie. Here are my answers. First one, I'm getting -1 to the, well, I start with n and see if that works. Plug in, say, n is 3, and you do indeed get that right there. Next one. Looks like I have cubes underneath the square root. So I have square root, then I have cubes, right? Yeah, n cubed. I believe that's right. Or if you want, you can write n to the 3/2. Next one. On top, I have -1 to the n. Nope, that doesn't work. Just by saying, when this is 2, oops, I get -1. So that's not good. So I have to fix that by putting a +1 there. Or you could put a -1, doesn't matter. On the bottom, it's going up by 3, right? It's going up by 3. So looking at these denominators, I see them going up by 3 each time. So I start with 3n, and then I adjust it by putting plus something. So the easiest way to do this is just to plug in 1. You could do something like 3n plus this number I'm looking for should equal 9 when n is equal to 1. So 3 plus x equals 9. So x is 6. So that gives me my 6 right there. Okay, then you can double check. Maybe you plug in n is 4 into here, and you get -1 on top. Yep. And on the bottom, you get 12 plus 6, which is 18. Hunky-dory. Okay, one can get a visual on these sequences just by graphing this as your kind of y, and then this is your x. So for the alternating sequence, we have +1 and -1. So, oops, should label that. So this is the n-axis, and this is the an-axis. 1, 2, 3, 4, whatever, 8. Wait, 5, 6, 7. Yep, I can count. Don't worry. So where do I start? When n is 1, I get -1. When n is 2, I get +1. Now I'm not connecting the dots here. This is not a continuous function. This is a sequence. Very different. So I just get this bunch of dots here. Okay, when n is even, I get +1. When n is odd, I get -1. And, so on and so forth. Oops. Haven't given myself much space here, haven't I? Oh well. For 2, I'm thinking about this line y is equal to -2x plus 3, and that's what I'm thinking about to guide me here. Now, what does that look like? Let's give ourselves some space here. So I start at, say this is 4, I would make this 2, bing bang bo, -4. Now, so this y is equal to 2x, whoops, negative 2x plus 3. I'm thinking about that. So the y-intercept is 3. So I mean, I wouldn't actually draw this dot here, because when you have a sequence, you start at n is equal to 1. So when I plug in n is equal to 1, I get just 1. And then my slope is negative 2. So that is down, you go down 2 over 1. And you end up here. Now, I screwed that up royally. I screwed that up. This should be, let's adjust this a little bit. Minus 2. My first red dot's a bit too high. Yeah, I would say my first red dot's a bit too high. Sorry about that. The first red dot should be right at 1. And my second red dot should be negative 1. Okay, because when you plug 2 in here, you get negative 1. And then my next red dot should be at negative 3. Okay, so this is all happening basically along this line here, which I do not draw. I'm going to erase it right now. But there's high graph, and I would continue. But maybe 3 dots is enough for now. Okay, moving on. Okay, we're now ready to define what it means for a sequence to converge. So pause and copy. So let's do this exercise. I want you to do this exercise, and I want you to guess the limit. Guess the limit. Okay, you'll notice here I didn't write anything under here. Because when we're talking about a limit of a sequence, it is always n goes to infinity. Okay, so you could write n goes to infinity here, but when we're talking about sequences, it's kind of understood that n is going to infinity. So it's not necessary to put that. Okay, I want you to try this graph here. It'll help us talk about this definition. So pause and try. So what do I get here? I'm going to give myself lots of space. Yeah. Trying to give myself some space here. I'll try to draw a reasonably accurate 2 plus 1 is 3. So what should I do? 2. Well, bear with me while I work this out. Just drawing a scale here. Label 1, 2, 3, 4, 5, 6, 7, 8. Good enough. Okay, where was I? Draw some red dots on here. Okay, so when n is 1, we get 3. Then we get, what, 2.5? Okay. Then we get 2 1/3. Oh, I should have a little bit lower. Let's say here. And then 2 1/4. Something like that. I can see, hopefully, that, let's try to draw a dotted horizontal line. What's happening is that I'm approaching this line, right? So my guess here would be 2. And, well, it's not really a guess. You can see that when n goes to infinity, this 1 over n approaches 0. Okay, so that's what we're saying. Okay, we're saying what is first of all, is the sequence approaching something? And if it is, we call that L. Okay, more technically, we say that the limit here is 2, because what you can do is you can say, oh, I want to be, this close. I want to be within this distance of 2. Well, I can get that close just by choosing n to be sufficiently large. Okay, it's going to be possible. Okay, a bit more folksy definition is just to say, well, the sequence is approaching 2. Okay, so let's find some limits of some sequences. So pause and copy. Now, first one, it's going -1, 1, -1, 1, -1, 1. Now, is this approaching anything? No, it's not. So this one we would say is divergent, right? Because this story is not going anywhere. It's just alternating forever. It never approaches anything. What if I divide by n? Well, that's a different story altogether. Okay, now it's alternating forever. However, it's the denominators are getting bigger and bigger, so it's being smushed. If I were to draw a rough picture of it, it would look something like -1. You see, it's going closer and closer and closer to 0. So sometimes you could just write a 0. Or you could say lim an is 0. Or you can just say L is equal to 0. I'm not too picky about the notation you choose. And for 3, we have square roots. Ooh, not making good use of my space here. Okay, for square roots, you have no no limit to how high they can go, right? It's impossible to put a ceiling on this expression. If you tell me its maximum is 1,000,000, well, I can find an n that will make this expression bigger than 1,000,000. So the limit here, it's going to infinity. So in this case, we say divergent. Okay, I haven't said so, but convergent means you get a real number. Okay, the limit equals a real number. A divergent means anything else, any other situation. Either it alternates forever, that's one possibility, or maybe it goes to infinity or it goes to minus infinity. Okay, but that's really the breakdown. If you get a real number, then you have a convergent sequence. If you don't get a real number, it's divergent. I'm going to have to do some algebra. To simplify this thing, to understand what's going on. Okay, so I start by using my exponent rule to simplify the first factor. Then I get what? I get 8, is that? And then I get times, or let's just put a bracket, 3 to the n over 2 to the 2n, which is 8, 3 to the n over 2 squared to the n. Which is 8. 3 to the n over 4 to the n. And finally, I get 8, 3 over 4 to the n. And if you want, you could think of this as 0.75 to the n. Okay, so I did some algebra here. And I got this expression. Now, what happens when you take 0.75 times 0.75 times 0.75? What's happening? Well, you can think of it as taking 75% of something. Okay, when you multiply by 0.75, that's the same as taking 75% of something. So I take 75% of one, and then I take 75% of that, and I take 75% of that. So I hope you agree that this is getting smaller and smaller and smaller with a floor of 0. Okay, in general, this is actually quite important. If you have a number, if you have a sequence, if an is equal to some number r to the power of n, if r is equal to, so if r is between 1 and -1, then an is divergent. Oops, no, I got mixed up. Then an has as a limit is 0. If the absolute value of r is bigger than 1, there you have an is divergent. Okay, if you think of something like 2 to the power of n, that goes to infinity, right? Or if you had negative 2 to the n, that goes to, well, it doesn't go to infinity anymore, but it certainly diverges. Now what about if r is equal to 1? Well, that tells you that an is actually just 1. And if r is equal to -1, then you get an is divergent again. Because you get an is equal to -1 to the n, which we've seen is just alternating forever. Okay, so here I'm saying that the limit of the sequence is 0. Okay, exercise. Pause, copy, try.